Welcome to 4.3, Fitting Linear Models to Data. It says video 1, but I think there's only going to be one video, so I guess it is video 1. All right, our learning objectives for this section are to be able to draw and interpret scatter diagrams, to use a graphing utility, and we're going to use Desmos to find the line of best fit, and to fit a regression line to a set of data and use the linear model to make some predictions. All right, let's talk about scatter plots. So scatter plots is a graph of data points, input and output, that may or may not show a relationship between two sets of data. So you have some data, you plot it, that makes a scatter point, just the points of data. There's different things that can happen when you plot data. You can see that in this first example here, there's a strong linear relationship. And if I just tried to sketch a line, I could say, oh yeah, I could have my linear model, that line be that line right there, and the data pretty much follows that line. The second one is a moderate linear relation, so I could draw a line like this. It more or less follows the data. That's the right idea. It's not great. It's not as good as the first one, but it's, you can see that there's a trend. The third example, there's really no line I feel like I could draw that models that data. And in the third one, this is a strong non-linear relation because I can see this is going to be like a parabola here. This is the shape that I want, and that is not going to be a line. It's going up and down. I can see a definite shape. So there's some different things that can happen when you're drawing scatter plots. Here are some vocab words. The first one is interpolation. Interpolation is when we use our model to predict values that fall within our data. So if I was trying to make a prediction, if this is my first example here, maybe this is time t equal to 0, and this is like 10 years later, I don't know, making up things. If I wanted to predict something that happened at 5 years, and I didn't have a data point there, I would be using interpolation because it falls within where my data is lying. The next definition is extrapolation. Extrapolation is when we predict values that are not within our data frame. It can be dangerous. It's pretty risky. So if I wanted to predict something that happened at 12 years, way out here, that would be extrapolation, or maybe 5 years before, t equals -5. Back here, that happened 5 years before outside of our data. That's called extrapolation. A correlation coefficient R is going to give you an indicator. It's an indicator of how linear your data is. It values from -1 to 1. -1 is a perfect line with negative slope, and 1 is if the data is a perfect line with positive slope, and it's going to look at the values between those two. So this first one here, this one, again, would have a positive R value close to 1. This would have a negative R value, but it wouldn't be as close to -1 because it's not quite as linear. And this guy right here would have R pretty close to 0. All right, so what we do is if we don't want to look at the -1 and the 1s, is sometimes we use R squared, which is the coefficient of determination, and that just ranges from 0 to 1. 0 being nonlinear at all, again, and 1 being either perfectly linear, either positive or negative. All right, so what we're going to do now is we're going to practice all this using Desmos. All right, so here's our data that we're going to look at. This data is the tuition from fall 2000 to fall 2009. T is representing the years since 2000, and C of T represents the cost per credit, so cost of one credit, T years since 2000. So before we get started putting this to Desmos, let's just practice with this. What is C of 4 in this data set? C of 4 equals, I'll use my table, C of 4 equals 54. And what does that mean in the context of the situation? Well, remember the 4, that's my years, and C of 4 is my dollars. I always like dollars per credit. I always like to write down my unit. It helps me interpret in the context of the scenario. So 4 years after 2000, so to me that would be in 2004, tuition cost $54 a credit. All right, now we're going to go to Desmos, and we're going to plot these points using Desmos and sort of answer the rest of these questions on Desmos. I can't show Desmos in this at the same time, so if you need to print this out or go back and forth on two screens, make sure you still have the notes up at some point. All right, here we are in Desmos, and we are going to use it to plot the data about the cost of tuition. So the first thing you want to do is you want to go to this plus sign and add in a table. and we're going to put our data into the table. If you want to change this to t, c of t, you can, but I'm just going to leave it as x1, y1. So the first data point is 0, and then I hit tab, 38, 1, tab, 39, tab, 2, 43, 3, 50, etc., 4, 54, 5, 56, 6, 65, 7, 66, 8, 66, 9, 74. All right, and you're like, yeah, but I don't see the data anywhere. And that's because if you look at what's going on in our data, our x values are from 0 to 9, so that's okay, but our y values are way up here at 38. So if we zoom way out, we'll see it. Oh, there it is. So this is obviously not a good window for this data. So the way I'm going to change it, I'm going to go over here to this little mechanic wrench, and I'm going to set the window myself. I want my x-axis to go from 0, maybe -1, just give myself a little space, to 10. There, that looks much better. And my y-axis, I'm going to go like -10 to 80. You don't have to change it one if you're happy with it, but I like that. Click back, and now you can just adjust it a little bit if you need to. All right, so that's using Desmos to plot the points, and there is my scatter plot. All right, the question next says, does the relationship appear to be linear, and how strong do you think it is? Yeah, I think it looks pretty linear. If I were to draw a line, I can see that I would draw a line like that, and I think it's pretty good. Say pretty linear. That's my answer to that one. Create a line of best fit model. All right, so to do that in Desmos, you're going to use y1. And how did I do y1 with the subscript is I actually have, I don't even know what I did, y shift underscore 1. So shift and then the button next to O gives you a subscript 1. And then you use the twiddle, which is above the dash, y1, and then you write m x underscore 1 plus b. And so you can use this to type any type of equations, any type of regression equation. I wanted one of the form mx plus b because I want it to be linear. The x1 and the y1 refer to my data values up here. If I'd used t and c, I would have typed t and c in there. And the subscripts, remember, you go shift underscore, which is right next to the 0 button. y1 equals mx1 plus b. So that's my line of best fit, and you can see it fills in my parameters right here. M equals 4.09091, B equals 36.6909. So that's my line of best fit. The next question says, what is the R value and interpret its meaning? R right here is 0.9864. And since we're looking at R, it's positive. That means this has a positive correlation. Slope is positive, and it's pretty close to 1, so it's a pretty good fit. Same thing, R squared also tells us it's a pretty good fit. All right, the next thing it tells us to do is evaluate CF15 using your prediction model and interpret its meaning. Well, there's a couple of ways you can do this. The way I like to do this is I actually like to just put the model into Desmos. So I'm going to go C of t equals, and now I'm looking up here for my m value, 4.09091 x, or t, whoops, plus, and then b, 36.69009. All right, so you can turn this one off even. That was our model. That's fine. I just copied it down so it looks like now here it's written using function notation. And it says to evaluate CF15. So what you can actually do is I just want to zoom out, right? CF15, keep going a little bit farther. There it is. There's CF15. Right here is 15. CF15 is right here, right? And its CF15 is 97.965, okay? Now you can plug in 15 equals to t and get the same thing, or you can actually go C of 15 using Desmos. Oops, I should use capital C because otherwise it's not going to know what I'm talking about. And it will tell me that it's 97.96455. So I feel like if you're doing computer linear regression, it's okay to use the computer to compute your function values. It's a handy tool. We're using it here. All right, so what does that mean, interpret its meaning? Well, 15 years after 2000, so that would be 2015, tuition was $97.96 a credit. I'm going to round to the nearest penny. So 15 years, 2015, tuition was $97.96 a credit. All right, the next question asks us, tuition in fall of 2015 was $100.93. How good was the prediction? Well, we predicted $97.96. That's pretty close. It's only not even, it's $2, $3 off, something like that. So it's a pretty good match, pretty good prediction. From part H, did we do extrapolation or interpolation? Which one was it, extrapolation or interpolation? Well, remember, interpolation happens within your data set, okay? So it would have had to be between 0 and 9 to be interpolation. It was out here at 15, so that was extrapolation, outside of our data set. Do you think this is a good model to predict for the year 2215? Why or why not? Well, what would T be for 2215? I think it'd be 215. I'm not even want to graph that. $916.14 a credit. Well, you can give your own argument as to whether you think this would be a good model or not. I'm guessing no, because it's such a huge extrapolation from where our data set is. Who knows what might be happening by then? Maybe college tuition will be free by then. So I would say it's not a good model because that year is so far past where our data set is. So that's how you use Desmos to do linear regression. It's a really intuitive, great tool. So much better than the way we used to do this on the graphing calculators. There you are.